Welcome to our class. Today we continue with our series of lessons implemented in Noir. And this time, just as last time, after we've written a circuit, trying to deploying it on Sepolia, and then doing verification of the deployed contract. So we deploy the contract and then go and verify it on chain. So that's what we'll be doing. So today's class, we'll be looking at modular exponentiation plus ZK proof in Foundry, and then do Foundry deployment on Sepolia. That's what we'll be doing. So basically, in today's class, we demonstrate how to create Noir circuit for modular exponentiation. Then we also show how to generate a proof, and then integrating the generated verifier .sol, the solidity verifier in Foundry. Then we do deployment to Sepolia. Then lastly, we verify on Etherscan. So those are the things we'll be doing in our lesson today. So that therefore means that by the end of this class, you're supposed to have known how to implement modular exponentiation circuit in Noir. And then you must also know how to generate a ZK proof using BB or bb.js. Then integrating the generated solidity verifier into a Foundry project, and I'm showing you how to do that. Then we do deployment of this solidity verifier to Sepolia, and lastly verify the source on Etherscan. We will also look at how to interact with the verified contract and confirm proof verification on chain. So those are the things you're supposed to know by the end of this class. Of course, the assumption is that you have the prerequisite of what is required for this lesson. In other words, we expect that you will install all the prerequisites or what is required to write this circuit and deploy it. So you should have your Noir installed, your Bartenet bug installed, Nago, and so on, all of them. If you have not installed what is required, then it means you have to check our earlier classes and learn how to install what is required for you to write Noir circuits. Now, so therefore, our circuit description is like this. It's modular exponentiation, where we have the base raised to an exponent mod, some modulars that should give us a result. So mathematically, this is what I'm referring to. That y should be given by x raised to e mod m, where e is the exponent and x in this case is the base, and m is our modulus. Now, so this, we want to write a zero knowledge proof. In other words, we will have some private inputs and public inputs. In this example that we are doing, our private inputs will include x, our base, and then the exponent. So this would both be private. But then the verifier will have to get to know what y and m are. These are public inputs. Y and M will be public. So both the verifier and the prover knows what they are, but these are private. So we want to prove, the prover wants to prove to the verifier that he knows an X, a private value X, another private value Y, such that X raised to Y mod M would give us Y. So Y and M are public, but X and E are private. So the prover has to show that, has to prove to the verifier that he knows what X and E are. And at the end of this, the verifier has to be convinced that indeed the prover knows what X and E are, but the verifier will not get to know what they are, what X and Y are. So that is the circuit you want to write. Then generate a proof for it, generate solidity verifier, and then deploy that solidity verifier on chain, on Sepolia, and verify. So our main .nr would look like this. So let the result be mutable. And we begin by assigning it 1. And the base will always be the remainder of the base. The new base will always be the remainder of the earlier base on a division by the modulus M. So, and we are doing that in the range 0 to 32, and so on. The exponent, okay, the result here will be given by the original result times the base. What remains when this is divided by the modulus, that is the result. Now, so this is how our main circuit looks like. Of course, I don't need to explain everything because as per now, we already know how to write this. Our main intention is how do we generate a solidity verifier and how do we deploy it and how do we verify the deployed contract on chain. So that is our main focus in today's class. Now, so the inputs, as I had already stated, our base is private. Our exponent is also private. M is public. M is public in this. M is supposed to be public here. Now, so our project structure would have circuits, and inside circuits would have our SRS with the main.nr. We also have build scripts, that is a build.sh, and then we'll have proof artifacts that all those will be inside our circuits. Then we said we would have a Foundry project. That means we'll have a contract, and we do forge initialize forge init to make it a Foundry project, so that we install the foundry.toml, and so on. We also have JS, and this is where we would be doing generation of proofs. So JS would have codes that will be enabling us to do generation of proofs. Now, this circuit can therefore be compiled by the current Noir, that is 1.00 beta 1.6 or BB, which is greater than, beginning from 0.84 to the most current. This is not the most current, but I will have the most current ones. So, but beginning from this, any of them would still run this. So it's compilable by any of these, so long as it's from this going up to the most current. Now, I'm aware that you know how to arrive at this, but for the sake of those who are joining us for the first time, maybe I can just take you again through the steps. But always remember to go back to our earlier recordings and see what we covered before to assist you be at par with us. Now, so I'll just show you how to create a project. Then from there, I'll go back to a project I already created so that we use it. So this is my WSL. This is Rust programs where I usually store my programs. You open yours where you always store. Now, so you want to create a new project, you can say make directory, new project, you can call it a name. Just call it that. And then you come inside this project. And we want to have circuits as one of our folders in the structure of what we want to create. So you just say make directory circuits. And then you can get inside these circuits, see these circuits. We want it to have Nago. So this is how you then create a project. When you say Nago init, that is when it now creates a project. So when I press enter, it creates a project. But now my Nago is not in the right path. And so that is why it's not responding. So for me to proceed with the Nago init, I need to make it be in the right path. Now yours could be in the right path, but mine is not. So I have to make it first of all be in the right path and then proceed with the steps, the other steps. So for my Nago to be in the right path, as we have always done, I would use this command, echo export path home, Nago bin, and so on. So when I press enter, my Nago will then be in the right path. So I can now go back to the command we had, Nago initialize, and you can see it as a written project successfully created. It's located at home, Cyprian, Rust programs, inside HHH, and so on. Now, so for me to open this project, I get outside the circuits, get to the home directory, then do squad dot, and then open. I just press enter. So when you press enter, it opens the project you just created, and I can now share it with you. I can now share this project with you. The one we've just created now. Now it's what I'm sharing. You can see on our left side, we have HHH. That is a project we created. When we did Nago initialize, the project was created and we expected to have SRS. We expect to have circuits. This is, we can see we have circuits. When I click on these circuits, I expect to have SRS, and it's there. I also expect to have Nago Tomil, and inside the SRS, I expect main.nr, which you can see here. Now it comes with the default main.nr, and this is now the one you replace with our circuit for modular exponentiation. This is what you replace. So you just delete that and replace it with your right circuit. Now that is how you create a project, and this was just for the sake of those who are joining us for the first time. But again, as we said, they needed to go back to our earlier videos and see what we've already covered. Of course, get to know what are the prerequisites, what do they need to install for them to be able to write in Noir and deploy contracts to Sepolia. So now I can stop sharing this. We continue with our slides. Now, so just for their sake, installation, you would want to clone and initialize submodules. And to do that, you'd use git submodule update, init recursive. You can try that. And of course, every time you're doing this, it's always good to follow the on-screen commands. They'll always be guiding you on what to do. I also want to build a Noir circuit and generate a verifier. So we have already showed you this part, CD circuits. Okay, for us, we have build.sh. This one is meant to automate the process of compiling and a generation of the verifier.sol. So that is what we do here. We automate the process. But if you want, you can do it manually. But as we've always said, it's better to automate this process so that you don't keep on pasting the commands manually every time. You can put those commands in a script to be there permanently. And every time you want to use them, you just say /build.sh, and it does all those commands for you. Now, for the sake of proof generation in the JS, you need to install yarn. And when you just cd JS and write yarn, or if you want, you can write yarn install, and it will install all JS dependencies, those that you require for proof generation. Now we will create a .env file at the root of the project inside our contracts. And this will just to safeguard our key that we'll be using from our MetaMask. This key is required for deployment. If we want to deploy our verifier.sol, we require this key. And so this key, we will get it from, and I showed you how to obtain it in our last lesson. But after obtaining it, we store it inside .env file and ensure that this .env file does not reach our GitHub. So we ensure that it is, of course, it is in gitignore. So gitignore has to ensure that this .env does not reach to our GitHub. We're just trying to safeguard this private key that we obtained from Sepolia because as we said earlier, if this private key gets into wrong hands, then you may have your account withdrawn. It may have people withdrawing funds from your account. And again, another thing we said about this private key, it's better you get it from an account without ETH. An account without ETH so that your ETH is not withdrawn on chain. Now, so let me share my code. You can also, if you want, you can also clone it from my GitHub. You can clone the modular exponentiation from my GitHub. Modular exponentiation project. You can clone it from my GitHub. Now, so these are our structure. As we already said, we would have the circuits, then we would have contracts, then we would have JS. Of course, you have gitignore just to ensure that what we don't want to go to our GitHub does not get itself there. We have the Git modules of the prettignore. This one you may not require the prettignore, but for me, I have it because I used Prettier to try and format my code so that the code is well aligned. So I use Prettier. So when you're using Prettier, and then it will come with this prettignore and so on. Then of course you require readme.md. Now let's go to our circuits. We have our SRC and the main.nr, which I had already shown you. We had already looked at the main.nr. Now the only thing I need to show is the build.sh, which, as I said, will be doing compilation of our circuits. And this part is assisting us to do compiling. And this part is helping us to do generation of verification key. And after generating verification key, we use it to generate solidity verifier in this step. So this is the step that is giving us the solidity verifier. Now, very important is this code. This is helping us to do a generation of the verification key. And it's using modular Noir modular exponentiation .json. So this .json is obtained in this step during compilation. So when you are doing compilation, the product of that will be .json. And this .json is stored inside our target. And so for us to generate or to write verification key, we require this. Now, again, we have this other command that now does the writing of the solidity verifier. And it's using the verification key generated just above. The verification key was generated and stored inside our target. So it's this verification key that is now used to write the solidity verifier. This solidity verifier, by default, is supposed to be stored inside our target. But you can see in my command, I've ensured that it's not stored there, it's stored inside our contract. By default, it will have been stored inside our target, and then we would have manually moved it to our contract. Would have manually moved it to our contract, and that manual bit, that manual movement bit is what I was avoiding, and I ensure that it goes there automatically to the contract. Now, so let me just delete our target so that we regenerate it. There are two ways of regenerating it: getting outside our contract where I am currently, then getting inside our circuits. Getting inside our circuits. You can generate that target by Nago compile. And Nago compile has given us our target, and it has also given us modular Noir modular exponentiation.json. Let me also delete the verified sol because I had already generated it. Also delete it. Okay, the other way of generating this target, I can again delete it. There's no problem. The other way is using our automatic way of doing it, using the build.sh. And the build.sh will be doing a number of things. You can see that it has given us our target. And inside our target, it has done Nago compilation and given us the same Noir modular exponentiation.json. And in addition to that, it has given us verification key. It has then gone forth to use this verification key to give us verifier.sol, which is our contract that will be deployed on chain. It has given us this. And you remember I had already shown you the command that it does this. Now, after this, after doing that, you may want now to generate our proof. So you get outside our circuits, get inside our JS. Now, for me, I've already installed yarn, but if you had not, you would then write install yarn install, or just yarn. Write yarn install, or just yarn, and then it will install dependencies. After installing dependencies, you will now do what I'm doing to generate the proof. Yarn generate proof. You do yarn generate proof. And just give it some time, and you can see it has generated the proof. It says proof generated successfully. Now our proof is here inside our target, on where I'm pointing on our left side. Apart from that, the other thing that has been generated is public inputs, which we had indicated in our circuit. There were two public inputs and there were two private inputs. So, but now here we have the public input, two of them here. Good. So that is how you do using JS. The only thing you need to remember is what is inside our JS. Inside our JS, as we've always done, this is our JS. And our JS, the most important thing you require is this generate proof.ts. Of course, we've talked about this for quite some time. And the other thing that is important is the package.json and then the tsconfig.json. And of course, this yarn, when you do yarn install, it will install for you .yarn, install for you yarn log, and so on when you do yarn install. And of course, even the node modules will come as a result of yarn install. So when you do yarn install, that's what it does. But now the generate proof.ts, this is a code you write yourself manually. I've shown you how to write it before in our earlier classes. And this one, okay, it comes automatically, but not as complete as it is. You have to do some editing, add a few things that you want, and eliminate a few. You can see I've added dependencies that I want, and so on. I've also added prettier right, and I'd already told you that prettier, I was using it to do, after you've written your code and you want your code to be well formatted. So you use prettier to do that, formatting your code. Good, so that is what is inside our JS. Now, every time you generate a proof, you may want to just verify that the proof is okay. So to verify, I've added a command in my README, this command, forge tests. That means, again, you should have install forge. And now to use this command, you get outside JS, then get inside our contract, and then run this command. Now, after running that command, you can see it says gas report, compiling, no files changed, ran one test for the starter.t.sol, and then the test passed. And it gives you some information here, deployment cost, deployment size, and so on. So there's a lot here. Then down here, we have the verifier.sol, the home verifier contract. Again, you're given some information here about deployment cost and the deployment size. So we've just verified our proof that we generated. So far, we've done quite a number of things. We've generated the verifier contracts, the verifier.sol. We've now generated the proof. And let me just show you what is inside the contract that is helping us do all this. First of all, this one, we created it ourselves. But there was some tests you saw in our results when we ran Forge test. We talked about the starter.t.sol as a test. And this one you write manually and add it here inside our test, contract and then tests. So this is our starter.t.sol. And the other one that helps us do this is this Cyprian verifier app.sol. And here it is. You can always go to my GitHub and see the exact code. Then we have the foundry.toml. Here it is. So these are the things that are helping us do that contract, that proof verification. The things that are helping us. Now, so we have used yarn generate proof to generate the proof. Now we can also generate a proof directly by the use of BB commands. So for you to do that, first of all, you have to get outside contract, then go back to circuits. And while inside circuits, you want to get a witness in your target. In your target, you want to get your witness. So for you to get a witness, you do now go execute. Now go execute. Now, when you do now execute, the witness is produced, and this is called Noir modular exponentiation. And we are told that this witness is saved inside our target. So when you come to your target, you can see Noir modular exponentiation. This is the witness we want to use to generate the proof. So again, to generate the proof, I use the BB command and I've added it to it's here. I've added it to my README. Just copy it and paste it here. I hope it's well written. Now, so the proof has been generated. Of course, it's the same proof like the last one, but so it has just been stored at the same point. We have an additional file of public inputs. They're just like what we had earlier, only that now the one we have, you cannot read it. It's a binary, cannot read it, but this one, the earlier one, we were able to read it. So we've generated the proof using that command. Of course, again, after that, you may want to verify the proof that has been generated using the same command, forge command we had used earlier. It's here. So you can use the same command, but you have to get outside circuits, then get inside contract, as we have always done. So once you're inside the contract, you can use that command and it generates it, it verifies the proof for you. And you can see the verification, what you get, the output will be the same as what we got earlier. So the output will be the same. Now, so far, what we've looked at is how do we generate a proof? How do we generate the verified.sol? So what we are left with is, after we have this verified.sol, how do we get it deployed and how do we verify the contract that is deployed? So that is what is left. But the initial stages, I've already taken you through them. So again, we just go back to our slides. For the sake of completeness, go through our slides, of course, what we have just covered here, and then look at how do we deploy and come back and deploy it. Now, so we'll come back to this .env. We'll come back to it. When we go back to our code, I'll be showing you that. Now, so just about proof generation using BB. This is what I had written, and I've already taken you through it. I'd said you generate the proof through bb.js helper. You can use yarn generate proof. Of course, you have to cd JS, then use yarn generate proof. Then after that, you would want to test, you would want to run Foundry test to verify locally. You want to verify the proof. So we'd used this command before when we were doing that, and we verified that. Okay, so again, that was one way of generating the proof. There's another way of generating a proof. And we've said you have to, first of all, create a witness, generate a witness with the nago execute. Then after that, generate a proof with this bb command. And you've seen how we've done that. Of course, after that, you can again verify the proof generated locally using the command forge, test, optimize, and so on. Now, I want to deploy it now. Want to deploy, and I've said deploy verifier to Sepolia. What do we require? First, we require Nago or Noir. All this you need to have installed them. Then Foundry, that is Forge and Cast. Then RPC endpoint or Alchemy or Infra. I showed you in our last class how to get the key from Alchemy, and we'll be using that key today in our class. And then Etherscan API key. Again, in our last class, I showed you how to obtain it. So we still will not be going through how to obtain the Etherscan API key and how to obtain the RPC endpoint alchemy. Of course, again, I'll not be showing you how to get private key from MetaMask because I already covered that in our last class. And of course, in our last class, the other thing we covered was how do you get free ETH into your Sepolia account? How do you get free ETH? Because we don't want to use our real ETH in deploying and testing our contracts. So go through our last video just to get yourself up to date with that information. Now we've already done Nago compile, Nago execute, and .build.sh. This part we already done, and we already know the expected output. Of course, we already have this output with us. Only that the second output here, the verifier contract.sol, although it's generated to be in target, we moved it to contract. So it's no longer in our target. We moved it to our contract. How do we prepare Foundry project? We already done that. We already done this. I said you would CD contract, then do forge init, and this would it will give you the foundry.toml, many things that it will install, dependencies that it will install for you. Okay, this part we are not doing it manually. Moving the contract, the verified.sol from target to contract, we are not doing it manually. We already instructed our build.sh to do it for us, to take the verified.sol directly to our contract. So we are not doing it manually. Now we are ready to deploy. So for us to deploy, first of all, we would want to write a deploy script inside our contract. And this is the deploy script. So that is what I'll now be sharing. I'll be showing you how to write the deploy script. And then after that, I'll show you how to write the env. And then we will update our foundry.toml and then deploy. Now, all the notes of what we'll be doing are inside my README. They're all here inside our README. Everything we require, even this is the env, this is the code we'll be using to deploy. And this is the script, the deploy.s.sol script. Now, so which way, therefore? You want to deploy, you come inside contracts and create a folder, call it script. Create a folder, call it script. Inside this script, create a file and call it deploy.s.sol. Now, you then go to my README there and copy the contents of deploy.s.sol and paste it. Let me show you what I'm referring to. This is my README, and this is the content of from line 166 going all the way up to line 180 is our what we need to do to paste here. Good. So we have the script that we'll be using to deploy. Now, inside contract, you would again create another file, and we call it, let me just come to contract, is here. Right click, new file, and the file is .env. And what are the contents? You go back to my README and copy the contents. So what's my README? My README is here. And what are the contents of .env? We had seen it somewhere above. I think it is somewhere above here. Create, yeah, it's here. This is the content of ENV. Now, the thing is, you have Sepolia RPC URL, which you are getting from your Alchemy. This link, you just copy it from the Alchemy. And then you have the private key, which you're getting from your MetaMask. And then you have the Etherscan API, which you're getting from your Etherscan. And I showed you all this, how to do them in our last class. So since we are through with the deploy, now this is my, so the other thing is the chain ID. This is for Sepolia. And then you have to add this part to ensure that your ENV does not get to GitHub, that it remains in gitignore. It's not taken to GitHub. Remember that this key has to be kept private. But of course, if you're exposing it like the way I'm doing, you ensure that it has no real ETH in it. Should not have, your account should not have real ETH in it. Now, if you want to do verification, you want to create, for instance, want to create a script that will assist you do verification. And then that script should be done inside our test. Inside our test, you want to do verification on chain to verify your contract on chain. So you can write a script, and that script is called verify. You come here where you have tests. This is where you have tests. And you remember we only had this, we only had starter.t.sol. So you can also add another test here. And you call it verify proof.t.sol. Verify proof.t.sol. And this is what will be helping you to do testing. Now, so the verify proof.t.sol, let me just paste that here. But this is not the one we are going to use. Let's come back to our starter.t.sol. Our starter.t.sol says that our circuit has two public outputs, public inputs, and one of them is 3, and the other one is 6. So that is the exact thing we do inside our verifier.sol, our verifier proof. We ensure that we have 2 public inputs, and then ensure that one is 3 and the other one is 6, the way it is in the starter.t.sol. So one is 3 and the other one is 6. I think that is what we saw here, 3 and 6. So that is what we saw, and that's what I'm doing here. So once we deploy it, we'll come back and change this. We'll come back and change this once we deploy it. Now, so let's go back to our README and check how are we going to deploy it. Inside our README, we had said would, this is the code we're going to use to deploy. So you're only changing this part, putting the correct Sepolia RPC URL, and then you change this part and put your correct private key. So I'm just going to copy this, and after copying it, I want to paste it somewhere where I'll be editing it from. I want to paste it inside my Nago terminal. I have some space here. This is where I want to edit it from. So I want to copy my correct Sepolia URL and my correct private key and replace there. So I have that information in my ENV. That information is there. So I just copy it. I hope I'm copying the correct thing. That is my private key. Come back here. Let me just close this. That was my private key. Just come here and paste it. Hope that is correct. And then I go back to my ENV and copy my URL. That is my RPC URL. Copy it and come and paste it here. Paste it here. Good. Now let me see if I can deploy this contract. So you have to ensure that you're inside the contract the way we are. Then paste the command. I don't know whether these slashes, backslashes are correctly put. Let's see what happens. I just want to scroll down. I see what happened. I'm not seeing where to scroll. But it's there. Now, it says, oh, good. I was expecting that. It has been deployed, but it's telling us that home verifier is above the contract size. The size is supposed to be 3112. No, it's supposed to be 24,574, but ours is 311112. So it's above, but it has been deployed. Now it ran successfully. Now, so just to ensure that this error does not, we don't suffer from this error, we can update our Foundry.toml. Just to ensure that we have the optimizer settings. So let me just come to our Foundry.toml. Where is that? Is here. So I just ensure that I have the optimizer settings. So this part here, optimizer true, optimizer runs 200. That ensures that that error is not there. I've added this other part. It's not necessary at this moment, but we'll be using it for verification of our contract on chain. So we'll require it, and that is why I've just added it there for that reason, because we will require it for verification. So we can again copy the same command And since we've rewritten our Foundry.toml, we can again run the same command and see what we get. Because the problem was that our contract was of bigger size than what can be deployed. Okay, so this time there's no problem. Let us finish for it to end. Okay, it has finished. There are some errors. What is the error this time? Did I copy the correct private key? It appears I did not copy it correctly. Let me just check. Oh, I think the problem was that command. I copied it and I pasted line by line. It's supposed to be pasted as a single command. It's a single command. So I think while I was writing it in my README, I did some spacing. And so when you do some spacing, it comes out as different lines. It's supposed to be same command continuous. So that is where the problem is. Let me see whether this one works. I've tried to ensure that it's one line. I don't know whether it's correct. Yeah, so every time you're using that command, just ensure that it's one line and not different lines. So I'll just go back to my README and change that command so that it's one continuous line. Unlike what I have here, it appears like there are several lines. So just change it to be one line. I want it to be this way. I want it to be this way. This is okay, but when I was replacing the values, that is when I got to the problem. That's where the problem came in. Now, so it has been deployed, and let's just look at the output and understand what the output says. The output says verifier deployed at this. So this is our address. This is our address. Let me just copy it and go back to the verifier proof.sol, and I said I will come back and change this address. I said I'll come back and change it. Okay. Now, the other thing that we see, other than this, okay, this one we know it. We had even used it. Estimated gas price, estimated total gas used. And ensure that when you are doing this, you are using the free Sepolia. The hash, and this is the same address. In fact, here written properly as address. On-chain execution complete and successful. Transaction saved at this. If you come to deploy under this contract, you have this broadcast. Under broadcast, you have deploy, and this is where most of the information has been stored. That is where it has been stored. Now, the contract there, we can go to it and just try to see how our I just want us to go to that contract. So let's just copy the address and we go online. Just a minute. So just back to, this is our address. Is it? Our address is here. So we want to copy this and go online using this address and see what we get. So we just stop sharing this, then share so I'm just pasting here, and of course I have to add HTTPS. Just a minute. Just a minute. So to see it, now this is the address. So you would go to HTTPS Sepolia ethscan.io address, and then you put our address. So when you press enter, you can see our contract is here. Now, it has not been verified. If it were to be verified, you would see it a tick, a blue, green tick here. So it's not verified, but the contract is inside here. but it has not been verified. So we need to verify it first of all. So let's just go back to, but we've seen how to arrive at that. Just a small thing I want to add to my README so that when you are looking at it later, you can always follow. I want to add something to my README. Why is it? This is my README. I come to, okay, we just deployed it. The example of the output is there. And what I want to add here is that if you want paste the deployment address, just a minute. If you want to see and interact with your deployed contract, paste the deployment address in browser. So the deployment contract, we are pasting it here. The address we are pasting it here. So our address was I can say e.g. Now I just copy this. And copy our address. And paste it here. So if you, no, not this way. It's supposed to be here. So that now, this is what you check. You check at this point, and you'll be able to see your contract. Now, we can also verify it. We can also verify our contract. We had already written our I can just copy this and replace it again. But this is okay. The only part I need to change is this. In the verifier dot, not even the whole of it. I just want to change a small bit of it. So when you come to my README and see what my README reads like, it's supposed to be home verifier payable. Home verifier and then payable.
So that is what I'll just change inside my verifier dot from verifier payable here. This is the part I just be changing. Then close it this side also. Close it that side. Now, for you to verify it, you require compiler. You require compiler, and in our last class, I showed us how to get a compiler. So, in fact, the command is here. You can just go back to our class, last class, and get the exact way how we're getting the compiler. But there's no problem. Even if you come here, let me see. Let me see. I just submit. Just a minute. Let me see whether it can also be obtained online. Our compiler. It's not there. It's not there. But I showed you how to get compiler in our last class. The commands I've given is you can just go back to our last class and get the commands correctly. After that, after getting what the compiler is, you would use this code. You would use this code just to verify. And again, straight away, I'll go to my Nagotomil so that I can try and write my command properly. This is supposed to be my address. The deployed address. And my deployed address is just here. I can just come here and copy it. And paste it here. And then the other thing I need to copy and paste is the ethscan API key, which I already have in my .env. So just come to my .env and get the ethscan key. And come back here and paste it properly. Then after that, copy my entire, I hope it says, supposed to be one continuous line. Supposed to be one continuous line, not breaks. So let me see if it will work. I am suspecting that it's not one continuous line, what I've just pasted here. Let me again try to work on it. Supposed to be one continuous line and not multiple lines. Okay, let me again try and copy this code properly. Again, copy it properly, and then so that we again repeat the process. I am going to the Nagotomil, paste my command there. My address is still here. I haven't discarded it. My address is still here. So I copy it and paste it here. Good. Then I come and copy the Ethscan API key inside my so here it is. I copy it and come and paste it inside my, where was that? Nagotomil, change this key and paste the correct key. And then take this code where it is, hoping that it's coming as continuous code. Good. It has worked, and there's something here. It says, we said forge verify contract. Then it is written something here. And what is important that I want here is the GUID. GUID. Okay, it says the response is okay. GUID is this, and then URL is this. So again, this is the same URL we used before when we went online to check to see our contract. So again, we'll just be using it to see our contract if it's verified. Now we can check if it's verified. We can check it here if it's verified from this manually on locally, or we go back to where our contract was and check whether it has now been verified. And I had already told you that if it's verified, it will now be ticked. It will now be ticked to show that it's verified. So let me just unshare this, and we go and confirm if it's verified. We just go on chain, go to where our contract was. And this is the same contract. You can see now this is green. And it's when I point at it, it says contract source code has been verified to match its own chain bytecode. Source code verification does not imply the contract is safe to interact with. You can see we deployed it 24 minutes ago. You can see now it has been marked with a green. And now the contract, we will now see the contract name, the optimization enable, yes. We have compiler version, the one we used is now there. And now our contract is the exact one we have on our local machine. Otherwise, what you were seeing earlier was slightly different. But now this is the exact one we have on our local machine. Now, if you want to interact with this, okay, these are things that are here. If you want to interact with it, and we'll be doing that next time, you will come here and click on README, on read contract. Click on read contract. When you click on read contract, you see connect to Web3, and we will do that. We will connect to Web3. And when you connect to Web3, it takes you to MetaMask. Here, click on MetaMask. Mine is MetaMask. So you can see it's connected. It's connected to Web3. And now from there, we can now, I'll be showing you how to interact with it now once we're connected to MetaMask. and ensure that when you're connecting that MetaMask, again, it's the same MetaMask, the free part, the Sepolia part, as we had already talked about. Now, so what we've just done, we've verified our contract on chain, and we've shown that it is verified. We come and show that it's verified. Now, the other thing, if you don't want to do that, you want to go on chain, supposing you want just to know whether it has been verified, and you want to do it locally, you will still come here. Inside my JITME, you'll find the command for doing that. And I've said here that you can confirm the JIT, the status of your contract. If it has been verified, you can confirm. And so this is what we'll be using. So I just copy this, and you can see I'll be changing my Etherscan API, and then changing the G guide. The guide, the guide is just here. Our guide is just here. It's just here. So that is those are the only things I'll be changing. So let me just come to my Nago where I've been working from. Paste that, and my guide is here. So using this guide, copy it and replace this with my guide. Place that. And then this, if I still come back to my ENB and get what it was, it is this, the Etherscan API key, go back to my Nago terminal and replace this, the exact one. Then my link, my code is now ready to verify. I just copy it and come paste it here. And I want to see whether it verifies. It says yes, response okay, details pass, verified, contract successfully verified. So you can verify your contract here locally, or you can still go on chain and verify your contracts. And of course, how are you doing it on chain? Just coming here and copying this link, or you can just click on it. Follow this, you can see it says follow the link. When you click on the link, it takes you straight to, I can say open or copy. Let me just copy. And then after copying, I go with it straight to my browser and paste it, and then press enter. Takes me to the contract, and I check if it's verified. I can see the same contract, it has been opened, and it's verified. So I think let's stop at that, and we'll meet next time. And next time we'll now be coming here, looking for this contract, and then interacting with it. Thank you.